Hey guys, short lesson today, but before we get started, I wanted to remind you to look on Google Classroom at the grading guidelines. It's also posted probably on the school website and on our Twitter, and it's kind of everywhere. So make sure you look at them and that you're familiar with them of what you are required to do. And so you don't like, oh, I didn't know we need to do that, or you just the rules and what's being expected. So today we are talking about the money multiplier. Yes, a new multiplier. We have the tax multiplier, we had the spending multiplier, but those dealt with fiscal policy typically, meaning like more or less changing in taxes, more or less changing in government spending and how that affects GDP. But this money multiplier is to do with monetary policy. And last week, if you don't remember, we talked about money, the functions of money, different types of money, and the categories. We talked about the Federal Reserve and their function, their main jobs, and the tools that they use, that they change to regulate money supply, and how that looks like on a money market graph. So I'll continue to be bringing these things in, but we're going to pause on some of that and talk about the money multiplier, which is the definition you can kind of see right here in this box. It says the amount of which an increase in deposits in the banking system is capable of increasing total money supply, assuming the deposit wasn't already part of money supply to begin with. Okay, bye-bye.
Hello.
Yes. Okay, so the money multiplier, basically, here's the equation that you're going to end to begin with. Like here is the money multiplier equation, which is M equals R, or 1 over RRR, where RRR is the required reserve ratio. So M equals 1 over the required reserve ratio. Ooh, there's a hair on my board. It's messing it up. Let's try that again. M equals 1 over the required reserve ratio. And if you remember from last week, the required reserve ratio is the percent of deposits that must be kept in the bank at all times. So this number is going to be a percent number. Of course, we're not going to keep it in like percent. We're going to keep it in decimal form. So I looked it up last week during office hours. I think maybe it was during a video. And I wanted to see what the required reserve ratio actually is. And right now, the required reserve ratio, the RRR, is 10%. So what that would look like on our money multiplier formula is 1 over, not 10, but 0.10. And we've done this before in terms of like, the spending and money, the spending and tax multiplier. We have been dividing by decimals. This isn't new. So, 1 over 0.10, we can move decimal places over and make this 10 divided by 1. Or we could say how many dimes are in a 1, or how 1 over 10, which I don't get how. I get you can do that. I just don't get the reasoning of how that trick works, but it doesn't matter. Old dogs, new tricks. So 1 over 0.1 is the same thing as 1 over 10, but it's 10. The answer is 10. The money multiplier, if this is true, and it is, the money multiplier today in real life is 10. Okay, I did an example here. Unfortunately, I cannot change the size of this, but it says, example, if the Fed requires the banks keep 20% of their total deposits in reserves, then RRR is 0.2. So in the example that I'm going to be using for the rest of this lesson, I'm going to be saying that is 10%, but it's 20%. So I'm actually going to erase this and erase this. So in this example, let's say they have raised the required reserve ratio from 10 to 20. So now it's 20%. So it's going to be 1 over 0.2, which if you remember correctly, I can move decimal places over and say 10 divided by 2, or I can say how many double dimes are in a 1, or this is 1/5, 0.2. So I can say what's 1 over 5? Either way, the answer is 5. Okay, so right now the money multiplier is 5. Okay, so what do I do with that answer? Or what do I do with that number? Here's the equation that you're going to be using. What we're solving for is change in money supply. Okay, that's because if you look at the definition, it says the amount of which a change in deposits, an increase in deposits, is capable of increasing money supply. So change in deposits, or I'm not going to say change in deposits because you don't, let's say that you deposit $100 in. $100 is not all going to be loaned out. Like you deposit $100 into the bank cannot loan out all $100. It has to keep, in this example, oh my gosh, loud. If you deposit $100 into the bank, the bank cannot loan out all $100. They have to keep a fraction, a percent of the deposit in the bank at all times. And so what they can loan out is 20% of this. And what they, okay, I'm probably going to have to edit that out. Rewind. In this example, you deposit $100 into a bank. The bank has to keep a certain percentage of money in the vault at all times. That's the required reserve ratio. In this example that I said that we were going to be using for the rest of this lesson is 20%. 20% is the RRR. So that means 20% is required reserves. That means the other 80% is left over. It's left over. We are going to call that excess reserves. So the money that can't be touched is required reserves. So we have a deposit. Ooh, if I could spell, that would be fantastic. We have a deposit. And it is split into, when you deposit money, it is split into required reserves, which you can't touch. You can't loan that out. And then whatever's left over, we are going to call excess reserves. And you can loan that out. You can. That is totally, you can touch. So in this case, we have 20%. It can change. You can have 20% required reserves and the other 80% is excess. So back to this problem, if it was $100, and I'm glad that I made it a really easy number, we can loan out 80 and we have to save $20. So here's what's going to happen. Change in money supply. How is that going to affect money supply? If you deposit $100 into a bank, it's excess reserves, that extra money that you can touch, that $80 in this example, that excess reserves times M, which is the money multiplier. This right here is the end equation. So change in money supply, like how does your deposit affect money supply? Whatever is left over after the excess reserves times M gives you that money, tells you what happens to money supply. So in this case, I want to erase some of this. My board is just too messy. In this case, if you deposit $100 in the bank and the required reserve ratio is 20%, it's going to be, you take 20% out of this number, whatever's left over is excess. So $80 times M. Well, what's M? Which is 1 over RRR, or 1 over 0.2, which is 5. 80 times 5 is the question that you were trying to solve. Excess reserves of $80 times a money multiplier of 5 is going to be $400. Meaning, if you deposit $100 into the bank, it is going to have a multiplied amount on money supply by $400. Because when you deposit money into a bank, yes, they loan out all 80 to another person who then deposits into their bank. And then that bank takes out 20% and then loans out the rest. And this process will go over and over and over and over again until you have changed money supply by $400. Okay, so here's the kicker. When you deposit money to a bank, you are actually creating loans for other people. And I'm about to be cut off, so I'm going to have to cut my lecture off short because I'm running out of disk space apparently. But here's the question that I'm leaving you guys with. If the Federal Reserve, I'll increase the size of this. If the Federal Reserve lowered the required reserve ratio to 5%, what would the money multiplier be? And if Jack deposits $100 and the required reserve ratio is 10%, what will result? Okay, so those are the two questions I'm going to leave you guys with. There's going to be an exit ticket, so make sure you do that because it's part of our grading guidelines. And I will see you guys later. Have a good day. Maybe. And okay, now have a good day.